Hi, uh, it is a long day for me, but let's do this. So I will create this video for the 2020 Set 3 end of year paper. So I have to first make a very clear statement that in 2020 it is the COVID year. So a lot of the things are new, and as a result, we actually lower the difficulty level of this paper. So please do not use this paper as a reference to the 2021 paper because most likely it will be a little bit harder. So that's why this 2020 paper is used as a warm-up exercise for you guys. Okay, the nature of the 2020 paper is really to check whether you have the baseline content. So in another word, if you are watching this video and many of the questions you encounter you got it wrong, please see your teacher immediately, because like I said, the 2020 paper is really a watered down paper due to the COVID situation at that point of time. Yeah. Okay. So what I will do is that I will try to go two page by two page. So first, question 1 is really on your prefixes. So as you can see here, that's why I say that this is basic content. We are just asking you what is nano. This paper didn't even ask you to convert. So chances are the paper that you'll be seeing this year, we will ask you to do some conversion. It won't be something like that we are trying to move away from checking whether the student has memorized something. That's not our intent for the exam. So maybe I will take this chance to run through with you how to convert unit, especially prefixes. So there is a shortcut. For example, if let's say I want you to convert maybe K amount of into maybe km, right? I try to use things that you are familiar, like and km, and I have decided not to use a number, but I give you a placeholder. So what is a placeholder? That means you can put any number into this place. So I use the letter K as my placeholder. Okay, you can put any number in it, 10,000, 0.2, 0.5, 0.23, whatever you like. So how to do this is quite straightforward. You just write down this as your template, right? And what you do is very simple. You need to know this mini, maybe I use red. This mini stands for what? Stands for what, meaning that like nano stands for 10 to the power of minus 9. So mini stands for 10 to the power of minus 3. And you also need to know what is this. This is K. Kilo means what? Kilo means 10 to the power of 3. So now that your mathematics should be able to catch up, the power here is the key to solve this equation. So maybe I use another color, maybe green. Okay, what you do is that you just need to put the new power, the old power minus the new power. Okay, so therefore this thing will become K times 10 to the power of 3 minus the new power 3. And you just need to press the calculator. Ta-ta! You have converted kmm into K kilometer. Okay, I will give you another example. For example, now you are being asked to convert 2 nanometer into, okay, maybe not nanometer, since you want another example, nanogram, okay, into maybe gram. So you may ask me, teacher, this one don't have prefix, so what should I do? Okay, if it is no prefix, then it is just 10 to the power of 1, not 0, because 10 to the power of 1 is, 10 to the power of 0, sorry. Because 10 to the power of 0 will give you 1, yeah, so it's 10 to the power of 0. So this nano will be 10 to the power of minus 9. So how do you convert? Use the template. 2 multiplied by 10, old power minus new power. So this will give you 2 times 10 to the power of O power minus 9 minus 0. Finish. This will become gram. So from 2 nanogram to 2 gram, this is how you do it. Still not buying it? Give you one last example. We have done with meter, we have done with gram. Let's do with time. Yeah. So let's say I want to do maybe okay, time. Okay, do you have kilosecond? Okay, maybe you have. Okay, never mind, we just create this. Okay, maybe 36. I don't know why I'm thinking about 36. Let's say 36 kilosecond. I want you to convert into a millisecond. So what to do? Kilo 10 to the power of 3, mini 10 to the power of minus 3. Right, use the template 36 times 10, then O minus nu. Right, so it will become 36 times 10 to the power of O is 3 minus bracket minus 3. Press the calculator and you have succeeded converting kilosecond into millisecond. Okay, so that is Q1. Okay, Q2 is about your micrometer screw gauge. I hope you still remember how it looks like. If you don't, just use your PLD Google micrometer screw gauge. So before I go into this, maybe I just want to highlight to you how to read the zero error. So here I have drawn out a picture when there is no zero error. So when there is no zero error, you should be able to see like half the marking over here. Okay, what is this green color marking? This green color marking is like there will be a part. Okay, let's say this is not 20, but this is like 0. This metal part will be just nice cover half of it. Okay, so that's why over here, wait, let me undo all these things. That means over here you will see perfectly half the 0 coming out. Okay, and then you will also see that this datum line, maybe I use yellow, this datum line will coincide with this datum line. So this arrangement will tell you that there's no zero error. Now I want you to compare that to your figure 2.1. Can you see that the whole green color part, that means this 0 marking, is now being eaten up by the spindle, right? So this means that in this case there is an over tightening. Okay, there's an over tightening. So if there's an over tightening, meaning that basically this jaw, right, you remember your micrometer should look something like this, right? Then there is this thing here that allow you to screw in, right? The more you screw this part in, then this thing will close onto the thing, right? And when it is in perfect condition, when it is just closed, you will see this. But sometimes due to wear and tear, this part of the rubber here will get worn off, and then you will find that you can over tighten it such that the 0 here will disappear. The green color 0 will get covered up. So because of that, even though when you read the datum line over here, it is aligned to the 47 line, but actually the difference that it has created, is just 0.03 mm, right? As you can count from here, 0, 1, 2, 3. This is the difference that it has created. So rather than just reading the value by its marking, right? Because here is 45, 46, 47. So rather than just reading the marking by itself, you need to understand how does this work. So when this happens, this is basically over tightening. You have over tightened 0.03 millimeter. So when you want to compensate this 0 error, you need to add back this 0.03 millimeter. So next, in your figure 2.2, I have indicated here actually how you should read. So this line, this is 20, then 21, then after that 22 is here. So what is this line? This line is actually your 22.5. So after you read the 22.5, read the datum line coincide with this, you will see that it's 23. Now this 23 is not 23 mm, but rather 0.23. So if you are just reading the 2.2 reading, this is the reading you get. Then after that, you must compensate the zero error, right? And then this is the reading that you get. Now take note, for this particular case, please do not round it up to 2SF. When you are reading, no need. So then after that, for part B, they are actually asking you how you can improve accuracy. So what is accuracy? Accuracy simply means how close you are to the true reading. Okay, that means if now I have two reading, 22.76 mm versus 22.7 mm. If now I ask you between these two, which is more accurate? You can't answer. You cannot answer. Because even though this has 2 dp and this has 1 dp, you do not know which one is more accurate unless I tell you that the truth, you know, the God value, the truth is it is 22.7. If I tell you now the truth is 22.7, then you can say that, oh, this is more accurate, it's exactly the same. This one, I have an error of 0.06, right? So accuracy is how close you are to the true value. It is not how many decimal point. So because of that, when you are answering questions like how you can improve on accuracy, you cannot suggest to use another equipment. Because for example, if you say that, oh, I don't want to use a micrometer screw gauge to measure, I want to use a more superior measuring instrument. I want to use a microscope plus a laser, you know, some super futuristic measuring instrument that can give you more decimal place. No, that doesn't allow me to get a more accurate reading. To get a more accurate reading, you need to improve. This is an I'm so sorry. Improve on the process. Now what's the meaning on improve on the process? It means that the way you make the measurement. So for example, if now you want to measure a person's height, what you can do, of course, you can get a taller person, and then this taller person can just put a stick like that, right? And then maybe from the stick, then it points to a ruler behind the wall and say that, oh, okay, you are 165, right? But as you can see, the person using the stick to align the top of your head with the ruler scale, the stick can be slanted, so it is not a very good process, right? So now what they do, they will ask you to stand in front over here, and instead of a person pointing a stick at you, maybe there is a device that is being mounted on a pillar, and then the person press this down until it rests flat on your head. So this will give you a more accurate reading, closer to the true reading. And this is what it means by improve in the process. Okay, so I hope you get the idea. So once you get the idea, here what I have done is that you are actually using the micrometer screw gauge to measure the diameter of the cable. So when you are talking about a cable looks round, right? But actually, if you zoom into this part, a cable may not be perfectly round. So meaning that even if you use a micrometer screw gauge and you close the jaw around it, right? Let's say this is the two jaw of the micrometer screw gauge. You will get one diameter over here, right? Then after that, if you decided to do other things, oops, wow, like jam. Okay, so just now you have that, right? But what if now you go and put your jaw like over here? Then you will get a different diameter, right? So what does this tell you? This tells you that you can take the average. By taking the average, you will be able to reduce errors like that. So what you can do is that, well, you can clamp the micrometer screw gauge this way, measure maybe D1, and then after that you may want to close the jaw like that, and maybe you can measure D2, and then maybe finally you can measure you can close the jaw like that, and you can measure D3. So in the end, you go and take D1 plus D2 plus D3 together, you divide by 3. This will give you a better diameter, right? Because by averaging it, you are reducing the random error. Okay, another way is also by saying that you can take the diameter at different length, along the different length of the cable. So maybe here you do D1, and then here you do D2, and then here you do D3. Right? So you can also do it this way. So there are two suggestions to write this. Number one is, of course, you can take the diameter reading along different section of the cable. So these refer to this, right? Section A, section B, section C, right? You take the diameter reading along different section, and then you can take the average. So that will give you a more accurate one. Or what you can do, you can reorientate your vernier caliper such that you are getting the diameter at different angle, at different orientation, and then you can divide by 3. So there are many different ways, okay? But the gist is that the idea of averaging must come into play, okay? And in order to get this one full mark, because there are two answer lines, you must tell me where do you obtain the different components like D1, D2, D3 that will enable you to get the average. Yeah?